Geometry, thanks for tuning in for another episode of Math with Mullins. Today we're looking at lesson 10.7, circles in the coordinate plane. So some things we're going to touch on today: how to write and graph equations of circles, write coordinate proofs involving circles, and then solve some real life problems using graphs of circles. First major thing we want to write down, and this would be a good theorem to have in your back pocket. So if you want to write this down on your theorem sheet, that'd be good. Let x, y represent any point on the circle. So you can see that example here. So I can travel all the way around the circle and x comma y would still represent any point there. The two things that could change that are where the center is located. So the center is always going to be located by h comma k. And the reason why we didn't rename these x and y is because we didn't want to get them confused with another x and y. So h is still in the position of x, k is still in the position of y, so you're going to notice that is still paired with x and y down here, and the radius r. According to the Pythagorean theorem, because hk would be the center, then we're able to make a right angle, so that means we could do a squared plus b squared is equal to c squared. So that means I can find the equation of a circle by doing x minus h squared plus y minus k squared is equal to your radius squared. So this is the standard equation of a circle with the center at h comma k and radius r. Make sure we have these things written down before we go on. So if you need to, let's pause the video here, and when you're ready to go on, click play. All right, so what we're going to do here is we're going to try to write the standard equation of each circle. So the first thing we need to find is the center and the radius. Okay, the center is located in the middle, and it looks like our center is at 0, 0. And then the radius is just how far is the center to the edge? 1, 2, 3. So our radius is 3. So what we'll do is we'll use this same equation we saw from before and just fill out our h comma k and our radius. Okay, so we would say that would be x minus 0 squared plus y minus 0 squared is equal to r squared, or 3 squared. Okay, so all we're doing again is filling in both of those things. Then we just simplify that. X minus 0 is x, and squaring that is x squared. Y minus 0, y, so that'd be y squared, and then is equal to 9. So this is the equation that we can use. We can't simplify it anymore. That just means as I try to build my equation, if I wanted to graph this eventually, I could make a table and plug in x and y values. The next one we have no picture, but we have the things we need. So here's our h, here's our k, and then here's our r. Okay, so we're going to do x minus 0 squared plus y minus k, so y minus negative 9 squared is equal to 4.2 squared. Okay, x minus 0 squared is still x squared. Y minus negative 9 actually stands for y plus positive 9 squared. And then 4.2 squared is just 4.2 times 4.2. So that calculation, is 17.64. Okay, so this is all that we would be looking for in that case. You are not going to multiply out this y plus 9 squared because we want to be able to easily find our h and our k. All right, so we're just going to keep it in that situation. So here are two examples that I want you to give a try. Go ahead and write the standard equation of each circle for the center and the radius that are given. Let's go ahead and pause the video here so you can try those on your own. When you're ready to check them, go ahead and click play. All right, my first one, I should have x minus 0 squared plus y minus 0 squared, since my h and my k are still 0, 0, is equal to 2.5 squared. So I'm going to get x squared plus y squared is equal to 6.25. Okay, for number 2, x minus negative 2 squared plus y minus 5 squared is equal to 7 squared. This will just change to x plus positive 2 squared and then y minus 5 squared still remains the same, is equal to 49. Again, we're going to leave the x and the y values alone here because this is going to help us figure out, okay, my h would be -2, okay, my y would be, or my k would be +5. Okay, moving on. Let's go ahead and try our next one. So this is when we're going to use that equation, or use a point on the circle, and kind of work backwards there to try to find our distance between the points to get the radius. So we have our point -5, 6 on the circle, and then the center is -1, 3. First, we need, in order to write that standard equation of the circle, we know my center is -1, 3, but what is my radius? So that piece is missing. So what I need to do first is find the distance between these 2 points. One method you can use is the distance formula. Another method you can use is Pythagorean theorem. So since I have a picture, I'm going to use Pythagorean theorem. 1, 2, 3. 1, 2, 3, 4. So that means the distance is 5. So from here to here is 5, since 3 and 4 and 5 are common triples. So that means my radius is 5. So now I can plug that into my formula. X minus -1, that's my center h, squared, plus y minus 3 squared is equal to 5 squared. So simplifying that looks like this. X plus 1 squared plus y minus 3 squared equals 25. Okay. Next, we're going to be given the equation, and what we want to do from that is be able to find the center and the radius of the circle, then graph it. Okay. So one thing we need to do here is we're going to be putting x's and y's together and then completing the square by adding something over 2 squared to both sides. Okay, so the first thing I'm going to do is go ahead and group things. So x squared minus 8x plus y squared plus 4y, and then equals a +16. So I'm getting my constant all by itself and then grouping my x's and my y's together. Okay. The next thing I'm going to do is try to complete the square by using this, a number b over 2, and squaring that. Okay, so this is what that's going to look like. My x squared minus 8 is just going to remain the same, but then I'm going to write plus my number with x, -8 over 2, and square it. Okay, this is called completing the square, and since I'm doing whatever I'm doing to this side, I'm also going to be doing to the other side. So my y's would be y squared plus 4y, and then plus y, which is my 4 over 2, squaring it. Okay, because I added that, I'm going to also have to add that same thing. So like, because I added this -8 over 2 squared, -8 over 2 squared is going to be added to this side, and because I added my 4 over 2 squared, I got to also add it to this side. Okay, so that's just balancing our equation. I'm trying to color coordinate this so you can see the differences there. All right, so what's going to happen is that's going to help me make my answer in the format of the odd equation of a circle. So this is what it's going to turn out to be. I'm going to have, oopsies, x squared minus 8x, and then -8 over 2 is -4, squaring that is 16. Okay, and then plus, here come my y's, y squared plus 4y, 4 over 2 is 2, 2 squared is 4, is equal to 16 plus 16 plus 4. Okay, so now what I could do is, because I have a perfect square, I would just be factoring or unfoiling both of these expressions to create that x minus h and y minus k. So x squared minus 8x plus 16 can be written in the form of x minus 4 squared. So if you tried to refoil that, this is just where my brain is going here. x minus 4 times x minus 4. If I do that first, outer, inner, last, I get x squared minus 4x plus 16, which is what this expression is, x squared minus 8x plus 16, okay? So that is why I completed the square, so that I could give those things there, and so I could balance that equation. So y squared plus 4y plus 4 can be written in the form of y plus 2 squared, okay? And then all that is equal to this 36. Now, this is going to help me find my center. So my center, because this is x minus 4, that means my center is positive 4. And then this should be y minus k. So that was y minus negative 2. That's where we get a negative 2, because we were seeing that reciprocating in the previous examples. And then my radius is just going to be the square root of 36, which is 6, okay? I did some crazy work over here, so I'm going to erase what I have here. If you need to go back in the video, you can, but I'm going to just erase this so I can have some room for my graph, okay? But this is the great thing about recording, is you can go back and look at whatever you need to. All right. So to graph this, I would do my center at 4, 2. So over 4, 1, 2, 3, 4, down 2. And then my radius has to be 6. So 1, 2, 3, 4, 5, 6. So from my point, 1, 2, 3, 4, 5, 6. I'm going to be going off the graph for that. So you only get 1, 2, 3, 4, 5, 6. About 3/4 of my circle. So I'm just going to try to sketch the circle as best as I can. For homework tonight, I don't give you that many sketching opportunities, just as long as you can find the center and the radius from given points, okay? I'm going to have you try these two. So go ahead and pause the video here, try these on your own, and when you're ready to check, go ahead and click play. All right, so for these, we're just writing the standard equation of a circle. We do not need to find the graph, but what we do need to know is this point, 3, 4 is on the circle with center of 1, 4. So we need to find the distance. Since I don't have a picture here, you could draw a picture and then see if the Pythagorean theorem works, or just do the distance formula. So distance formula, remember, is x2 minus x1 squared plus y2 minus y1 squared. So I would say this is my x1, y1, x2, y2. So I'm going to do 1 minus 3 squared plus 4 minus 4 squared. 1 minus 3 is negative 2. Negative 2 squaring is 4. And then 4 minus 4 is just 0. So my radius is equal to 2, because that is my distance from the edge of a circle to the center. So now I'm going to take the center, here's my h, here's my k, and write that in my equation form. So I'm going to have x minus 1 squared plus y minus 4 squared is equal to 2 squared. So that simplifies to x minus 1 squared plus y minus 4 squared equals 4. Okay? Number 4, the equation of a circle is x squared plus y squared minus 8x plus 6y plus 9 equals 0. Find the center and the radius. I'm not going to have you graph this one. If you did graph it, congratulations, but that is okay. You probably already know how to graph what points go where and how to sketch that based off of this example I did here, okay? So first thing we want to do is group our x's and y's. So x squared minus 8x plus y squared plus 6y, and then is equal to negative 9, okay? That was step 1. Step 2, we're going to complete the square by using the number with my variable not being squared. So I'm going to have x squared minus 8x plus negative 8 over 2 squared plus, here come my y's, y squared plus 6y plus 6 over 2, squaring that, equals, I'm going to go and change negative 9 to green. So you can see that I'm going to also add what I added to my x's, negative 8 over 2 squared, and my oranges to add what I did to my y's, 6 over 2 squared. Okay? Next up, we're going to see what happens here when I complete this square. So I'm going to have x squared minus 8x, and then negative 8 over 2 is negative 4 plus squaring that is plus 16, and then for my y's, plus y squared plus 6y, 6 over 2 is 3, 3 squared is 9, and then is equal to negative 9 plus 16, and then plus 9. Okay, my first one to complete the squares of my x's, that's the same one we saw from earlier, x minus 4 squared plus, this one's new, y plus 3. So you're just basically taking the square root of 9, and that square root added together should give you this middle number of 6 squared. And then negative 9, positive 9 cancel out, so all that's left is our 16. Okay, so my center, this is x minus 4, so that means it's 4 for my x, or my h, and then this should represent y minus a k, so that would be a negative 3. So you're just using the opposite of the numbers you see there. And then my radius is 4, because that's the square root of 16. Look good? The last few things we're going to talk about is proof statements, and then talking about maybe some ways to use this with real-world application. Prove or disprove that the point square root 2 times square root 2 lies on the circle centered at the origin, contains the point 2, 0. Okay, so the first thing I want to know is what is my distance between the origin and the known point, and then the origin and point in question. Okay, so prove or disprove that this point, the square root of 2, square root 2, is in the circle centered at the origin containing the point 2, 0. So we're going to use 2, 0 first as my x and my y. So to find the radius, I'm just going to find the distance between that. Okay, so 0 minus 2 squared plus 0 minus 0 squared. Not exactly sure what that other y point is or my other x points, so that's why I'm giving you zeros first. And because it says it's centered at the origins, that means my other point is 0, 0. Okay, this is going to give me negative 2 squared, which is 4. So basically this square root of 4, so my radius is equal to 2. Okay, yay, found that. Now, because I know my radius is equal to 2, then I want to see how does that relate to this point. Okay, so I'm still going to do the distance formula again, but now with these x's and y's using that origin. Okay, so let's see how this works. I'm going to do my x2, 0 minus square root 2 squared plus my y's, 0 minus square root 2 squared. Okay, these are just going to give me, kind of look weird for now, negative square root 2 squared plus negative square root 2 squared. Okay, which in the end just gives me 2 plus 2, which is equal to the square root of 4, which is 2. So this radius is also 2. So we have the same radius from one point. So like we know it's centered at the origin. Does square root 2 lie on the circle? Yes, because everywhere we go around the origin, we should have that same radius of 2, right? So same radius. So square root 2 is on the circle. Okay, hopefully that helps you. You're essentially just comparing your circle center, which is the origin at this point, and then seeing if those 2 points in question give you the same radius. One way this could come up in a word problem is if you were looking at, we've seen like earthquakes before. So when you look at the epicenter of an earthquake, that is like from the center going outward, that would be your diameter. You would just take maybe your radiuses and compare those to see where they all overlap and what they all have in common. Okay, that'll conclude our lesson today on 10.7. Hopefully this video helped you, give you some insight about how to write some equations of circles in the coordinate plane. and tune back in next time when we do our nice review of Chapter 10. Have a great day.